Welcome back. So we are learning about the mesh analysis, and we have solved many examples about a simple mesh with the only voltage sources, current sources, super mesh, and with the dependent sources. Now let's have a look at another circuits with the dependent sources. So we have this circuit, and we have four loops here. So first thing, we will define the current through each loop. That has been basically defined as I1, I2, I3, and I4. And after that, we need to write the equation for each loop. Okay, so we will do the same thing. For example, we can start with this one. So because this is a source, current source, which is not shared between any loops, so we can say that basically current through this loop will be direct 4 milliampere. So I1 will be 4 milliampere. Okay, so we got basically our first loop current. Okay, then we can come to this loop. Why? Because this is the current source again, not shared between the two. So I can say that basically I2 is nothing. I2 will be the same current like this one, because this will be the same current. So that is will be Vx over 2k. Now this is a dependent current source because this current value depend on Vx. So we need to find out where is the dependent variable in the circuit. So if you look at in the circuit, we can find out Vx is basically the voltage drop across 2 kilo ohm. So we can write an equation for this dependent voltage source. So that comes out to be basically what? Vx can be written as. So through this resistor, two currents are flowing. One is I1, which is basically coming from this side, and one is I3, which is basically coming from this side. So polarity plus is here. So I can write this as basically 2 times of I3. Why I3? Because positive is here and the current I3 is flowing like this way. I3 minus I1. So this is the equation for this dependent variable. So we can plug in here. So I2 basically will be what? 2 times of I3 minus I1 divided by 2. So we already know the value of I1. We can plug in here. Okay. So this 2 and 2 will be cancelled. So we have basically I3 minus 4. So that is basically is equal to I2. Okay. So I can rewrite this I2 minus I3 is equal to minus 4. So this is basically my second equation. Okay. So now let's come to the third loop. Okay. Let's write for the I3. Okay, now we can start again from this source, which is basically nothing, a dependent voltage source here. So what will be the equation? Minus 1k times Ix. Ix is the dependent variable here. So we will look into this. Then the drop here, so that will be 2 times of again I3 minus I1. So what is I1? 4. So I can plug the value directly here. Then the voltage drop here across this 1k. Okay. So what is this drop here? Again 1k times. Now what is the current flowing through this one? I3 minus I4 is equal to 0. Okay. So the k could be like just divided. At the end we will get basically the same. Okay. Now here we need to write the equation for basically dependent variable, which is Ix. So Ix is the current flowing through this 1 kilo ohm. So what will be this current flowing through this one? So again two currents are flowing, one is I4 and one is I2. Okay, so I can write basically Ix is nothing, just I4 minus I2. Okay, and plug in the main equation. So it will basically become minus Ix. Ix is minus I4 plus I2. Okay, like minus sign will change. Then plus 2 times of I3 minus 8. Then again plus I3 minus I4 is equal to 0. So let's rearrange it. So we have I2, then we have 2 times of I3, this I3, so that will become basically 3I3. Then we have I4, so minus I4 minus I4, that will be minus 2 times of I4 is equal to 0, right? So this is my equation for my third loop. So we are left with the last loop. So let's write the equation for this loop now. So we can start again from anywhere, wherever you like. For example, if you start from here, so that will be plus 1 I4 minus I3. Then here this voltage drop here, okay, across this one. So that again 1. So now what are the currents flowing through this resistor? I4 and I2, right? So it will be I4 minus I2. Then we have here plus 12 is equal to 0. So we have I4 here, we have I4 here. We have I2 and I3. So it will be minus I2. We have minus I3. Then I4 and I4, it will become 2I4 is equal to minus 12. Okay. So basically we got our 4 arranged equations. Okay. So this was our first one. This is our like equation number 1. This is my equation number 2. This is my equation number 3. And this is my equation number 4. So we have 4 equations and 4 for each loop. So basically 4 unknowns. So one value is already found. Okay, so basically 3 equations, 3 unknowns. So you can solve these 3 equations to get all these values. So for that, simply like we can write them again. Okay, you can solve like using Gaussian elimination, or you can use some like software like MATLAB or other ones. We can use scientific calculators. So or simple like matrix technique. Okay, so we rewrite our 4 equations. We can convert them, okay, in the matrix form in terms of the coefficients. The first coefficient like I1 is 1. So there is no I2, I3 and I4 here. So we can put those values is equal to 0. Then here for this one I1 is 1. Okay, again we can plug in the values also. Okay, so I2 is basically 1. I3 is minus 1 coefficient value. There is no I4, so it will be 0. For this case, there is no I1, so 0. I2 is 1, 3, and minus 2. And the constants will come to the other side. So basically, we can say that this is A and this is B. And we want to find this uh, matrix of I. So I will basically is equal to what? A inverse of B. So take its inverse, multiply with B. And if you solve that, that will give us the value of currents also. If you do that, so these are the value of the currents, okay, that we can find. So this value is basically I1, this value is basically I2, this value is I3, and this value is I4. All are in milliampere, okay. So this way we can find all the loop currents for this circuit. So we can solve like we have 3 equation, 3 unknown. You can also use the substitution. So like you can use your preferred technique to solve these equations. The important thing is we can correctly get these equations that we can use for the further analysis. So this is how we will solve a circuit with the multiple dependent sources. Thank you so much.